Hi guys. So today our focus is on phylogeny. Okay. Got to get it to go through all the steps. Okay, so get me out of the way and then we're good to go. Okay, so when we're talking about phylogeny, we're focusing on the concept of systematics, classification of organisms and determining their evolutionary relationships. So how are they related to each other? How do we group them and how are they related? So obviously within this concept of systematics, we have taxonomy, the naming and classifying. And so we learned about that when we learned about domain, kingdom, phylum, class, order, family, genus, species. Dumb kids playing carelessly on fences get splinters. And then we have phylogenetics, which is our hypothesis of the evolutionary history of basically how these are connected to one another. So we're going to use phylogenetic trees to show those connections or show those evolutions. So this picture over here on the right is actually from one of Darwin's journals. Okay, so to determine these evolutionary relationships, scientists are going to use the fossil record, DNA, proteins, homologous structures. So all those things that we were talking about in that evidence of evolution video and set of notes. So phylogenetic trees are going to be diagrams that represent these evolutionary histories, these connections. And so you can see we can have them in a variety of shapes. So they're really similar to the concept of cladograms, except these trees are going to show the amount of change over time based on the fossil record. So this is not so much showing you how as different characteristics came into play, which is what cladograms did. So in cladograms, each line is representing a specific lineage, and then each branching point is what we call a node. So nodes are going to be common ancestors. So when we're talking about Panthera, we have two nodes. We have a branching point. Those are our nodes. And that node, right, that point where they branch off is our common ancestor between these two groups. Nodes and all the branches from it are called clades. So all of these are going to be clades, and sometimes we have clades within clades. Species in a clade are going to have some sort of shared derived feature. So there's some characteristic that we had down here when we branched from in the Panthera that all of these organisms are going to share some specific feature. So each of those are nodes. The root is the common ancestor of all the species. And so right here where we have Panthera is actually what we would consider the root. That's where all of these other ones are branching off from. So two clades that are merged from the same node are considered sister taxa. And a lineage that evolves from the root and remains unbranched is the basal taxon. So here's our root. The basal taxon just spreads straight out. It doesn't do any further branching, whereas all of these branches up here, these are our 6 sister taxon. Okay, synapomorphy is derived character shared by clade members. So what is that characteristic that they have in common? A derived character is similarity inherited from the most recent common ancestor of an entire group. So if we're just talking about these two organisms, then we're going to have, here's the common ancestor, that's going to be the characteristic. If we go further down, if this is the common ancestor, then we're saying all 3 of these would share. Ancestral characteristics are similarities that arose prior to that common ancestor. So if this black common ancestor is the one we're talking about, any of the traits that were derived prior to that would be our ancestral characters. So it's all about what you're comparing and what you're looking at. So when we're talking about cladograms and trees, we have an out group and we have an in group. We want the out group because that has to be kind of the lineage that's least closely related. It's almost like our base reference point that we're going to build from. We can have monophyletic groups. These are going to have the most recent common ancestor and all of the descendants. We can have paraphyletic groups. So we have the most recent common ancestor, but we do not include all of the descendants. We're only going to include some of the descendants. And polyphyletic group does not include the most recent common ancestor of all the members in the group. It's just going to include some. So here's our monophyletic. Here is our paraphyletic. And here's our polyphyletic. Parsimony. So if we have a conflict among characteristics, we've got different characteristics that kind of seem like they don't fit together or they don't follow along properly, we use what we call the principle of parsimony. We're going to use a hypothesis that requires the fewest assumptions. So what we're saying really when we say the fewest assumptions, the fewest changes to the DNA. Remember back in one of the other notes, I talked about the fact that when they discovered DNA and they started doing the DNA for different organisms, they actually had to rearrange some of the relationships on the tree of life due to those DNA connections or differences. So, what is the common ancestor for butterflies, moths, and flies? So A, B, or C. Which of those is going to be the common ancestor for butterflies, moths, and flies? The correct answer is C. Notice that is the closest ancestor that includes all three of those. What is the basal taxon? That would be beetles. Notice that from the original node, we branched and it just kept going. These other ones divided multiple times, so they would not be basal, they would be sister taxons. What is an example of a sister taxa? And so the butterflies, moths, and flies would be sister taxa. Okay, so here we have a data table. Plus represents the presence of a trait, minus represents the absence of a trait. And so what it wants you to do is create a cladogram that would best represent the data. So I would suggest you pause the video here so that you can see the data and sketch this out on your own. I'm going to give you a moment. Please pause. Welcome back. Hopefully you did pause and draw your actual sketch before we put the answer up. But here is the best representation that we notice as we go along. D has the least in common. And then as we add characteristic 1, that's E. B has both characteristic 1 and it now has a new characteristic. And so we've gone and branched off based on the characteristics that they have. Okay, here's another setup. So I want you to pause, please, and create your cladogram. So please pause. Welcome back. So looking at these specific concepts, here is our best connection, and notice that we actually have a branch off of a branch on this one. Okay, another practice. So we're going to look at this data table and we're going to determine which of the provided cladograms best fits this. So you may want to stop and sketch out or come up with your own so that it will help you determine. So if you pause for a moment so you can look at all of the options. Welcome back. So the correct answer would be A. That one is going to best represent the data provided in the table. Okay, so hopefully that helps you out, and we'll be back for more videos. Bye.